Okay, this is part 4 of this paper, Edexcel IGCSE Physics, January 2021, paper 1P. So we went through 3 parts before, so I think we got up to question 7 based on my notes. I did them a couple of days ago, and I'm just restarting to do the rest of the paper today. We'll do questions 8 and 9 next. If you watched the previous videos, thank you very much. Please make sure you support the channel by liking, sharing, and subscribing. I'm getting quite a few subscribers adding to this list, probably because people are getting ready for their mock exams or their module exams if they're doing A-level international. Okay, well, question 8 should be coming. There it is. So it's to do with solids, liquids, and gases. It's about the gas laws. So a student uses a computer simulation to investigate the motion of particles in a gas. He records the pressure of the gas and the mean speed of the particles in the gas at different temperatures. Now obviously you can't find the mean speed, so this is a simulation. Practically you can't determine the mean speed, so in the simulation it must be telling you what the mean speed of the particles is. And the reason they use speed is because obviously the motion of these particles is random, so they're moving in all sorts of directions. So we can't talk about velocity because the mean velocity will probably be 0 in any 2 directions. So mean speed will be more accurate here, if that makes sense to you. Okay, so at different temperatures, now you'll notice that the temperatures on the x-axis is given in degrees centigrade, and if you've studied this topic, you'll know that there's also temperature in Kelvin, which you need to think about. Okay, and then the pressure is given in kilopascals, and remember that air pressure, atmospheric pressure, is about 100,000 kilopascals. So here the pressure is in kilopascals. So this is 2,000, it ranges from 2,500 kilopascals to almost 5,500 kilopascals as the temperature changes between 0 degrees centigrade and 300 degrees centigrade. So that's the range that we're looking at. Okay, so the graph shows the results. So the first one is putting the pressure against the temperature in degrees centigrade, and the second one is the temperature, the same range of data in temperature from 0 to 300, and this time they put the temperature against the mean speed. And you'll notice when I first looked at this, I didn't notice that this one was a curve. You'll notice that this is a slight smooth curve going through the points, and you should also notice that the data on the y-axis is not going to 0 in either case, and that's probably because it's not been measured in Kelvin. Yeah, if it was in Kelvin, you would know that pressure and temperature are directly proportional, so it should go through the origin. So there is no origin here, and also if it was in Kelvin, the mean kinetic energy rather than the mean speed, the mean kinetic energy of the particles is directly proportional to the temperature in Kelvin. So those are some basic facts that you should make sure you have in your notes. And then now we come to the question. Give a reason why the student does not start the y-axis scale from 0 on either of his graphs. Well, I kind of mentioned it. So any sensible point that you make, and you can have a look at the mark scheme, and I think I've got the mark scheme attached to this exam paper, so I'll have a look for you to show you what's possible. But really, it's anything that you can think of in the exam that will give you the mark. So let's actually go and have a look at the mark scheme for question 8. I'm sure I have it. Yeah, normally I attach the mark scheme to my answers, so I can refer to it. So So that there is no data at value of 0 degrees centigrade. These are the points that they're making. Yeah. Idea that the pressure of the gas or the speed of the gas cannot be 0. Certainly it cannot be 0 at the temperatures that we're talking about, which was the temperature we're talking about is between 0 and 300 degrees centigrade. So the only time the pressure will be 0 would be at 0 Kelvin, which would be minus 273. So the idea that all the data would be bunched together at the top of the axis if they had gone to the origin, okay? So they wanted to spread it out. So really there is no right or wrong answer for this question, and you just got to hazard a guess when you're doing it, okay? So hope that helps. I think it's an awkward first question for question 8, okay? So back to question 8. Here's the graphs. You can see it's not going to 0. So they wanted to basically show the range of the data that they're using. So they've decided to spread out the data across the scale. You don't want all your data bunched up. So that is a valid point. Okay? So you have to decide what to do. And these are not kind of questions that you can really prepare for. But the more questions you do, the better you'll get at thinking on your feet. And then it says, describe the relationship shown by the two graphs. So graph 1 was a linear relationship, yeah? So graph 1 is linear, constant gradient, whereas graph 2 has a decreasing gradient. It's a smooth curve, yeah? It's non-linear, yeah? So it's a curve, so it's non-linear. And as the temperature increases, the pressure increases, you could say. Or you could say as the temperature increases, the mean speed increases or the average speed increases. So any of those 3 points will give you the 3 marks. Hope that makes sense. Part C, explain why the value of temperature chosen in the simulation should not decrease below minus 273 degrees centigrade. Well, if it's a simulation and it's been made properly, yeah, then it will be impossible to go below minus 273 degrees centigrade, because it's minus 273 degrees centigrade is absolute 0, yeah? It's the coldest possible temperature, yeah? So it is not possible to go below this temperature. So if it's an accurate simulation, it should be set so that minus 273 degrees centigrade is when you've taken all of the movement out of the particles. So at 0 Kelvin, or minus 273 degrees, all movement ceases, yeah? So all movement, speed, kinetic energy, it would stop. Yeah, at that value, only then would pressure be 0. Yeah? So these are the points that you can make, and there are 3 ways of getting those points. So these 2 lines here are the same marking point, whereas the first 2 lines are standalone marks. Okay? Part D, then, this is quite a long question, by the way. Part D, the student then calculates the kinetic energy of a single gas particle at each temperature, yeah, using the curve of best fit, yeah, remember that's graph 2. Determine the mean speed of a gas particle when the temperature of the gas is 100 degrees centigrade, yeah? So they want you to look at 100 degrees centigrade, yeah? Show it on the graph if you're doing this. Use a ruler. Try to be neat, and if you do it, you'll find that at 100 degrees centigrade on the smooth curve, if you go back to the graph and have a look, you'll see that the mean speed, if you draw lines from 100 degrees centigrade, you will see that it is actually, here's 100 degrees centigrade, so I've drawn green lines going up. So over here will be the value, that you need to read off the scale, and they just want to see that you can show you're working on the graph. So these lines are part of your working out. So do show those and make sure you use a ruler if you can. Okay. Once you've done that, back to the question, you'll see that the mean speed is 520 meters per second. And then it says the mass of a single gas particle is given here. Yeah. Now it's very small because we're talking about microscopic or much smaller than microscopic particles. Yeah. So that's 5.3 times 10 to the minus 26 kilograms. So if we know the speed and we know the mass, then we should be able to calculate the kinetic energy. Yeah, so they want you to calculate this kinetic energy, yeah, of this particle at 100 degrees centigrade. So all you've got to do is to show that you know the equation for kinetic energy is half mv squared. We got the v from D1 above, from the graph, so, and we know the mass given to us in this question. So you would just have to put them in the equation, and it's a very difficult number to put in, so you need to make sure you know how to use standard formula calculator, and don't forget to square the speed, so 520 squared. And if you do that, you should get the kinetic energy to be about 7.2 times 10 to the minus 21 joules. I've put it to 4 significant figures, yeah, and then shown the examiner that I know that I should round it up, because if you think about it, most of the data we're provided with is known to 2 significant figures only, so you should really quote your answer to 2 significant figures. Hope that makes sense. And then it says calculate the temperature of the gas in Kelvin. Yeah, so if you've got to do it in Kelvin, to go from to Kelvin from centigrade, you have to add 273. So that's the formula that you have to use. So if it was 100 degrees centigrade, then it will be 373 Kelvin, because remember the Kelvin scale starts at minus 273 degrees centigrade. Yeah. So for example, if the room temperature is 25 degrees, that will be 298 Kelvin. Question keeps on going, so this is the final part. On the axes, they want you to sketch a graph of the average kinetic energy. Yeah? The average kinetic energy against temperature in Kelvin. Yeah? So average kinetic energy against temperature in Kelvin. And if you do that, it should always be a straight line going through the origin, because when you have the temperature in the absolute scale, which is Kelvin, then it's always the average kinetic energy of particles is directly proportional to the temperature in Kelvin. That means if you take out all the temperature, you go to the coldest possible temperature, which would be 0 degrees centigrade. At 0 degrees centigrade, the kinetic energy will also be 0, because basically you've taken all of the heat out of the material. So that's a solids, liquids and gases topic, and we finished question 8, which was quite a long question. Question 9 is on waves, ray diagrams. So it's from unit 3 on waves. So a student does an investigation to determine the refractive index of, of a block made from glass, flint glass is called. She directs a ray of light at the block as shown in diagram 1. So you can see where the ray is starting from at the bottom of the diagram, and it showed the direction that it's going in. So it goes through the air, hits the glass at an angle to the normal, which is a dotted line, yeah, and it then refracts, bends towards normal as it goes into the optically denser material. When it comes back out, the ray will go back in its original direction. Okay, So the ray coming out and the ray going in are in the same direction in terms of the angle that it will go back in terms of the amount that it bent towards normal. It will now bend over here. It will bend away from the normal over here. Okay, so that's not what they're asking you to do, however, but that's how you draw ray diagrams. Some of the light, it's saying, is reflected at A, yeah, from the surface. So not all of the light gets through into the glass. Some of it will be reflected, and you need to draw this reflected ray, yeah, draw this reflected ray of light, and all they want you to show is that you know that the law of reflection is that the angle of incidence, yes, so the angle it hits the glass at will be equal to the angle of reflection. And remember, all angles are drawn to the normal. Okay, so you need to make sure you've drawn the normal. And you see, as long as they see that the light going in, yeah, this light going in and then coming back out, if the angle is roughly the same, then you'll get your accuracy mark. Just to the eye, they will not measure it. And then here, and this is why I've told my students they need a protractor for this exam, use a protractor to determine the angle of incidence and the angle of refraction at point A on diagram 1. Well, if you got your protractor and you know how to use it, one of my students said they don't know how to use a protractor. Well, it's time to make sure you do before your exam, so that the angles that we're drawing, yeah, one should be about 60 degrees and the other should be 31 degrees. So if you look at it, this angle here, this one should be about 61 degrees, and this one should be about 30, whatever I said it was, yeah, degrees. So those are the two angles they want you to measure, and they want you to measure them to the normal. You never measure the angles to the boundary. So 60 and 31, and they'll have a range of your accuracy, and if you're within their range, you'll get the marks. So make sure you know how to use a protractor. State the formula linking the refractive index, yeah? The refractive index is N, and the angles, the two angles, angle of incidence, angle of refraction. Well, the equation is N equals sine of the angle of incidence over the sine of the angle of refraction. Okay, now I think writing it like that should be fine. Remember, you're given this equation in the formula sheet, and then once you know that equation, you can put the numbers in, the angles that you've measured, and once you put the numbers in, you will see to 3 significant figures, you will get the answer of 1.68. Make sure you got your calculator on degrees. Okay, so it's 1.68 to 2 decimal places, or 1.7. Yeah, you could put it as 1.7 to 2 significant figures. Yeah, because we probably don't know it that accurately. It then says, describe how the student could improve her investigation to obtain a more reliable value of the refractive index, one that you can be more sure about. Now, reliability is normally to do with checking that you've measured it precisely. Okay, so the first thing you would say is take repeat readings, yeah, at each angle of incidence, obviously, and take repeat readings and find the mean value, yeah, for both the angle of incidence and the angle of refraction. Okay, so once you do that, the whole point of repeat readings is to take a mean value. Okay, and you should say mean, you shouldn't say average. Average is a very general word. Okay, and obviously you have to measure, each time you change the angle of incidence, you also have to measure the corresponding angle of refraction. Okay? So these are points that you need to make. Now, to improve her investigation, she should vary the angle of incidence. Yeah? Obviously, you don't just do it once and put it in the equation. And you want a range of values, yeah, at regular intervals to get at least 5 sets of data. Okay? In GCSE, I always say 5 sets of data. Yeah? And then once you've got 5 sets of data, instead of just calculating it once, you can plot a graph of sine I against sine R as I've sketched here, and that should go through the origin. And if you do that, this is the correct scientific method for working out the refractive index. And then you may have some points, you might have some points which are above the line, some points which are below the line, and having a graph allows you to draw the line of best fit, yeah, which will give you an average of all of your data points. So it will be more reliable. So line of best fit will be the most reliable value you can get for the refractive index. So the graph should give you a straight line, and the gradient of the line will be the average or mean refractive index that you will calculate. And that in physics, they always want you to have a graphical method if you can. Okay, they don't want you to just do it once and calculate it in your table of results. They want you to do the line of best fit. And this is even more true when you do A-level physics. And then part B, the student replaces the red light with a blue light. Yeah. Now, obviously, red light and blue light have different frequencies and wavelengths, so they will also have different angles of refraction in the glass. Okay. So diagram 2, that's shown below, shows a ray of blue light directed at point X, yeah, at point A, sorry. I don't know why I said point X. So point A, directed here, same place as we had originally, and at the same angle of incidence as the previous ray of red light. So originally they did it with red light, and now they're doing it blue light. And the dashed lines that were already drawn, yeah, shows the previous path of the ray light, of the red light. Okay, so they've shown how much the red light bent, and they want you to work out what's going to happen with the blue light. Okay, so the refractive index, it says for blue light, the refractive index for blue light is higher. That means it will bend more towards the normal. I haven't drawn the normal in. So the normal would be, badly drawn. The normal would be drawn at A using a ruler. Don't know how I can change the ruler. Oh, there we go. It's good having the functionality of a ruler. I'm just making sure I draw it accurately. And then you draw the ruler, there you go, I managed to do it with this digital ruler. So that will be the normal, yeah? Move the ruler out of the way. So when you see the blue light here, this angle that it makes, the blue light, is bending more towards the normal than the dotted line, which was a red light, because it says, yeah, it says that the refractive index for blue light is higher than the refractive index for red light. So I put here, yeah, it will bend, so I can't put everything on the page. So it will bend towards the normal more than the red light, okay? So we have to complete the diagram by drawing, yeah? So you've got to complete the diagram by drawing the path of blue light from point A until it passes back into air, okay? So that's what I've drawn. I've gone there and I've drawn it then moving back in the same direction as it was traveling originally, okay? So you get 1 mark for showing that it will bend towards the normal, more towards the normal, and then 1 mark for showing that it comes out and then starts to move back in the direction it was traveling in originally, yeah? So in other words, red light and the blue light should be more or less parallel to each other, okay? And that's how you get the final 3 marks for this question. Hope that makes sense. And that's the end of question 9. So I'm going to stop the video here, and there's 2 questions left for the final part of this run through. So if you found that useful, please like it, share the video with your friends, and make sure you subscribe so you know when I've uploaded the next video. Thanks for watching. See you in the next video. Bye for now.